Bright Duty. Every student matters.
What are metals? What are non-metals? How do they? What are the physical properties? What are their chemical properties? Which included how they react with air, water, with each other, and with different solutions of different metals. Now we will be entering a more practical aspect. We'll be understanding how is it that the metals exist in nature, how do we retrieve them from the rocks, and how do we make them useful for our day-to-day use. So for understanding extraction of metal from ore, we first need to understand what is ore and what is a mineral. Now the difference here is very simple. Ore and mineral are essentially both forms of rock which have a metal in them, but from a mineral it may or may not be possible to extract a metal economically. So a mineral may have, say, only 10% of a particular metal, and to extract that we would have to spend a lot of money. Then it's not a feasible thing to do. So anything from which it is economically, and it's like even the processes that goes with it. So if it is feasible to extract an element from something, then it is called an ore. Whereas any mineral is basically a substance, a piece of rock which has different metals and different kind of particles in it. So ore is different because it is feasible to extract metal from it. Now you know that all of the metals that are around us exist in the earth's surface. They do not exist in air or in liquefied form. They exist in earth's surface in forms of rocks. These rocks are essentially minerals, and some of them are more suitable for extraction of elements. That's a more feasible process economically, as well as in terms of the processes that go in it. So from which it can be extracted, they are called as ores. Now for all elements, we have already understood that they can be divided on a reactivity series. So some elements like sodium, potassium, calcium are highly reactive. Other elements like zinc, iron, lead and copper are mildly reactive. And even further, gold and silver are low reactivity elements. So when we arrange them on this fashion, we also know that elements which are more reactive will be more difficult to extract because there will be a different process to extract them. They will be combining with different elements in which the lower reactivity elements will not combine. So that is why for our convenience we have divided this into three parts: how to extract low reactivity metals, how to extract mild reactivity metals, and how to react highly reactive metals. This is a process, a flowchart, which will show you exactly how the process is to go about. So the first process is concentration of ore, which essentially means to purify it, to remove all the dirt, the soil and the sand from the ore. Then for the low reactivity metals, they're often formed in form of sulfides. So we go through a process of roasting. What is it? We'll understand as we go. But we reduce them and then we change them into oxide, and then finally have the metal. Sometimes they also exist in free state. So elements like silver and gold actually do exist in free state also. That means they exist just as they are. The elements of medium reactivity either exist in form of carbonate ores or in form of sulfide ores. That is, in their ore form they have found a compound with carbonate or sulfide ions. And for the respective process we use calcination and roasting, and we get oxide. So we reduce them to form oxide first, and then from oxide it's very easy to reduce the metal to form to get the pure metal out of it. For the highly reactive metal, none of these processes will work because they have such strong affinity for their respective carbonate, or in the form that they are. That is why we only have one option of electrolysing. So we do electrolysis of the molten ore and we obtain pure metal from it. So what we have understood so far is that metals can essentially be divided into three categories of high reactivity, medium reactivity and low reactivity. and there are different processes for all three. So as we go further, we'll be exploring the processes in all three directions. There are also two steps which are general. First is concentration of ore, which essentially means cleaning the ore and removing all the impurities from it, which are not like part of the ore as such, but which are deposited on it or are present within it. And the last is purification of the metal, which is again a similar process in which the metal that we have obtained might have some impurities. So to remove those impurities, this is again a process which can be used for all types of metals.